The release of Qwen 2 has been completely insane, not just because it's already trading punches with Llama 3 and the latest models from Mistral, but because it teaches us a lot about how China thinks about AI differently than a lot of their Western counterparts, specifically Meta and a lot of other players in big tech, some of whom are really concerned about safety, when it's clear based on this and some other really incredible releases from Chinese AI companies this week, mostly pointing at Kling, that they just play this game differently, and it just shows that the game going forward is different than it will have been played in 2023, when a lot of this technology was in its nascent early stages and we didn't really know how it was going to be used. Obviously, the United States has placed massive restrictions on China, basically what GPUs they can buy, what kind of talent can be there, what kind of even chips production talent we're willing to even have in China. But I think there are a lot of interesting implications to go over here. This model is incredible, and I also want to go over some of the latest fine-tuning work that has actually showed that Qwen 2 is one of the easiest models to eke out lots of performance from. So welcome to AI Flux, let's get into it. So Qwen 2 was released on June 6th. So I've waited a little bit to see just how the evals turned out. And fortunately, to my surprise, they basically were being completely honest about the performance that they were able to achieve with this model. So one of the lead developers on the Qwen 2 project posted this on Twitter, and this is kind of their announcement for this model. So they say, after months of efforts, we are pleased to announce the evolution from Qwen 1.5 to Qwen 2. This time, we bring you base and instruct models of 5 different sizes. They always give us a number of initial quants that are pretty interesting to look at, which are interesting because it's hard to tell where this model is really intended to be used. So they range from Qwen 0.5b all the way up to Qwen 272b. They also claim that these have been trained on over 27 additional languages besides English and Chinese. One curious thing with Qwen is that generally it has performed better in Chinese than English, but that also makes sense. And a lot of the quirks with this model's reasoning have also been tied to logical reasoning and how that's actually defined in Chinese and how that's different with English. So they claim that this is granting state-of-the-art performance in a number of benchmark evaluations, significantly improving performance in coding and math, along with extending its context length. So taking kind of a hint from what Mistral has been doing and where a lot of people doing fine-tune, and basically what's been done with a lot of the more exotic fine-tunes of Llama 3. So they've extended the context length to 128,000 tokens, and what's curious is the size of the model they chose to support this. So right now this is supported with Qwen 2.7b instruct and Qwen 2.72b instruct. Now the benchmarks basically speak for themselves. So what I think is cool with Qwen 2.72b, at least in their initial passes in these benchmarks, is that the margin is clear. Obviously, in GPQA, the margin's a little small, but otherwise, we're seeing at least a 4 to 6% margin of improvement in performance. And I think a lot of this really comes from the focus of math and coding, because we've basically realized in a lot of these models that if you fine-tune on top of data sets that have something to do with coding or language encoding, a lot of that does carry over to kind of a greater logical reasoning capability. So their blog gets into a little bit more technical information as to how they actually achieved this. One thing that I think is interesting is that they're initially more forthright with just this stock Qwen 2.72b model, and they're a little bit skittish with giving results for Qwen 2.72b instruct, which I think probably is more useful for most people who want to use this model. One thing that I think is interesting is the two things that they really mention in terms of making this leap in performance is something that they call rejection sampling for math, and a number of different approaches they've taken, which are basically just online DPO training and doing some interesting work on optimizing merging and understanding how these steps actually further align their model with things that they want. Rejection sampling is actually something we've seen in a number of fine-tunes of the latest Mistral models, which has been kind of interesting, and it's cool to see this now kind of be, in a more academic sense, used in really big models coming from organizations that are far separated from a lot of the work that we see coming out of the West. Again, their biggest focus here was on coding and mathematics, so I'll try that out in just a bit when I demo this. And again, I think the biggest win or the biggest focus in terms of the current state of the art in June of 2024 is long context understanding of what that actually means, specifically how it's not necessarily RAG. So RAG was very popular in mid-2023 up to about the beginning of 2024, with the idea being that you could feed a lot into it and a system using RAG or implementing RAG would be able to understand it and give you reasonable context. And basically the way that we decide if a large context is actually giving you a benefit is with a needle in a haystack benchmark. So basically how quickly it can find something in a massive set of something it doesn't know, and then understanding the context around it to find it. What's interesting with needle in a haystack is sometimes it's more than just finding a specific element, but it's finding a specific element that's wrapped in a very specific context, which actually then makes it useful to use these models for things like sending in, thousands of emails or bills that are 60 pages long or 600 pages long. That's when you really get a win from this. And they show us this test with Qwen to instruct, and curiously, they don't show it with the non-instruct model, but it kind of makes sense in this context. So basically, there was a 100% pass with this initial context length. Obviously, it starts to break down with its accuracy of retrieval as they continue to increase the context length and as the models actually get smaller. So obviously, the 72B instruct model is going to perform really well, but what's cool is we can see that Qwen 2 7B and 72B instruct basically have a very similar relative level of performance. There's a curious kind of drop off right around the 40K context window length, which is, yeah. And then of course, the biggest irony of this entire paper, in my opinion, is that just to basically make fun of people in the West, they've included a safety and responsibility disclosure, which is just hilarious because clearly anyone developing this technology in China does not care about using copyrighted data. They do not care about using data from YouTube, transcriptions from YouTube. All they want is the most performance, and they're doing the best they can since we've, in my opinion, rightfully kind of restricted GPUs in that area of the world, because it's quickly becoming clear that supremacy in AI is becoming a defining hallmark of who has the power of information in the world. And I think that's kind of an important thing to bolster and protect. However, I don't think it means that we should wildly restrict open source models. So I want to jump into Hugging Face to see if we can get this going. And let's see how this model actually performs. And I'm going to see if I can use the instruct model specifically. So I'm going to start with what I'm calling the mirror test. So basically, it's trying to get the model to understand that I'm seeing something differently in a mirror than I'm describing, and having it figure out that, well, yeah, you shouldn't be able to see more things in a mirror than actually exist. So basically, we're just trying to see if this confuses the model or if it tells us that we're just going nuts. So what's interesting is it looks like it's taking what we're saying as truth and it's trying to explain to us while we're maybe seeing an optical illusion, which is interesting. It says try moving around the room, try to see how the reflections change. What's interesting is it doesn't actually reference what could actually be happening here. Like basically, there are certain cases where, depending on the object, like if it's an object that has a design that's perfectly mirrored, right, or perfectly in parallel, in theory, if you had it too close to the mirror, it could look like a single object or it could look like two of the same object. So that's kind of what I was trying to get it to say here. And we got kind of a lukewarm answer. So we got something pretty much saying, if you're seeing more objects on your desk in the mirror than you actually place there, it's likely due to two reasons. Either there's something behind you that is being reflected, or there is an optical illusion occurring. And of course it didn't say, or you're just a Westerner who hasn't been educated thoroughly. But fortunately, so let me try some basic coding questions now. I'm going to just ask for a Python function that will help me figure out some basic things about a sphere. So basically, I'm just asking this to write a function that will help me estimate the size of a sphere in an image with something that I've placed in it with a known scale. So not really a computer vision question, but something that it involves some more spatial reasoning than just like write a Python function for a Mandelbrot set, which I know a few of you did not like that I was asking that question. And here we go. So it says to estimate the size of a sphere in a picture where you have another size scale. We're doing some basic trigonometry and looking at some specific perspectives. All right, so it understands we have to use a scaling ratio and understands that basically any angle you're looking at a sphere, you're going to have a pretty consistent notion of its size. Keep in mind that this method assumes that both the sphere and the scaling object are in focus, that the camera lens does not significantly distort the image. And there's something here for pixel density. The one thing is it assumes that what we have for scale is a ruler, but that's a fair assumption. Okay, that's pretty interesting. So now I want to do something that's a more common coding task. So I'm going to clear the history here, and I want to, so now I'm going to say in the system prompt, you are a helpful coding assistant. And I'm going to say I want to make a basic landing page. And to be clear, this is the 72B instruct model. So basically, I want to see if this gives us code, if it understands that React is JavaScript, and mostly that it has kind of a good hold on the English language relative to code. All right, so similar to GPT-4, it's telling us to set up our project and install some basic systems. It's writing a bunch of CSS now to figure out the dark mode toggle, basically that we want to toggle a bunch of this CSS with a React kind of button. This all looks pretty good so far. And actually, it's pretty quick too. I wonder what GPU they're actually running this on. All right, so now we have a landing page. But one thing I'm curious of here is if we'll run out of context space. I don't think we will, but I'm curious how long they're going to let this go on their public kind of demo endpoint. Wow, so this is still going. So I'm curious if you guys want to see more examples of common kind of coding tasks or just common games. I like to avoid those because, again, there are a lot of existing examples of those that are probably in the data sets used to train these models. So this is actually pretty good. I mean, obviously, it's less than the full project, and it's lacking a little bit of the indication of what the structure should look like, which I think for a beginner, like if it assumes this person didn't know what they were doing, maybe that would have been a bit better. But this is basically as fast as GPT-4, and I think it's pretty cool that it understood exactly how to separate the light theme and the dark theme. And obviously, it was intended to be a pretty simple page, so I think this is pretty cool. But there's some things I want to cover before the end of the video that have to do with some interesting observations about this model. So one thing that I found pretty interesting was a point made by Tensor Taxes. And you should definitely follow them on Twitter if you're interested in AI stuff. And they raised this post on the local Llama subreddit, which was observing that basically the way this was created, that basically this model was having some really interesting quirks when people were further quantizing. Basically that certain quants were showing far more kilobytes per token, which then affected performance, which is kind of interesting. So specifically cache quantization, and basically the assumption here is that the 7B version probably uses really aggressive GQA, which then limits kind of what you can do after the fact. So I just wanted to mention that. And then also we'll have a video coming for Eric Hartford's work with Dolphin 292, or based on Qwen 272B, which is really cool because it's basically some of the best performance we've seen with them coming right out of the block in terms of the gains they made on top of Qwen 272B. Which, again, I think is a direct result of Qwen basically just not lying in their benchmarks and having some really interesting different means of achieving more performance over Qwen 1.5B. So I'm curious what you guys think about this model. Do you think that China maybe has a better approach in terms of optimizing performance, one that's also making some pretty serious compromises with safety? Do you think the West is probably still in the lead here with open source AI? What do you think about these open source models still being totally open, where both sides can kind of sample and learn just as quickly? I'm all for keeping all of this open as long as possible, but I'm curious what you think. So let me know in the comments below. As always, I hope you learned something, and if you like this video, please like, subscribe, and share, and we'll see you in the next one.